There are several steps for hypothesis testing when we have an independent samples z-test for a difference of two proportions. There are a few preliminaries. First of all, we want to state the target population. Are you interested in all Americans? Are you interested in all Germans? Are you interested in all people living in the Ivory Coast? Think about what your population really consists of. Then what you want to do is you want to state the parameters of interest. So in this case, we're actually interested in the difference of two proportions in the population. And then we want to check that there are at least 5 successes and failures for each group. Then the 5 steps for hypothesis testing are as the same as before, with some slight modifications. First of all, we want to state the null and alternative hypotheses. Then we select the significance level alpha, which affects our critical values. It affects our the benchmark by which we compare our p-values, and it will affect our confidence interval. Then we compute the z-test statistic. We assume the null is true, and then we make a decision by comparing that test statistic with some critical value, or we compare the p-value with the significance level alpha, where the p-value is calculated based on that z-test statistic. Then we state our conclusion, and then of course we can conduct a traditional confidence interval. Step 1, state the hypotheses. So the null is usually that the two sample proportions are the same in the population. So their difference is 0. So for the purposes of this course, we're really going to focus on this null that in the population, if there's no difference between the groups, then P1 minus P2 will equal 0. So if the proportion one population is 0.8 and the proportion in another population is 0.8, that difference is 0. There's no difference between those two population proportions. The alternative, all right, is that for the purpose of this course, we're going to focus on a two-sided test. Right? So the alternative will simply be that they're different, that P1 minus P2 is not 0. Right? That's the alternative. You can conduct right or left-sided tests for the difference of proportions, but for the purpose of this course, we're really going to focus on a two-sided z-test. The reason is that this is by far the most common alternative test when you're dealing with a difference of two proportions. Step 2, we're going to choose a significance level alpha, just like before. We're going to use alpha to compare and make a decision using our p-values. Alpha will also determine our critical values by which we compare or make a decision using our test statistic. And alpha also affects the width of the confidence intervals. Of course, remember that alpha is the probability of a type 1 error or a false alarm. For step 3, we will compute the test statistic. For the two independent sample z-test with a two-sided alternative, the z-test statistic is that difference in sample proportions minus 0. That's because the null hypothesis is 0. Right? The null is that there's no difference in the population between these two groups. So that's where we think that sampling distribution for p hat 1 minus p hat 2, we think that's where that sampling distribution is going to be located. Then we divide by the standard error, where the standard error is given by P1 times 1 minus P1 divided by the sample size for that first group, plus P2 times 1 minus P2 divided by the sample size of the second group. And you take the square root of that. Basically trying to add in all the variation and take the square root of that. We typically don't observe P1 and P2 because those are proportions in the population. So we'll use the sample proportion, in this case P1 and P2, to calculate the standard error. For step 4a, we will compare this test statistic with some critical value values. The critical value is based on the significance level alpha. Since we're focusing on a two-sided test where the alternative is that that difference in the population proportions is not equal to 0, that difference is either less than or greater than 0, meaning the first group might be greater, P1 might be more than P2, or P2 might be less than or greater than P1. The point is that the alternative is that they're just different. So we're going to use the following critical value for making a decision. If the z-test statistic in absolute value is greater than or equal to z alpha divided by 2, then we're going to reject the null that the difference in proportions in the population equals 0. Then what we can do is we can also calculate a p-value using our z-test statistic, and we can compare alpha to that p-value. So since we're focusing on a two-sided test where the alternative is that difference in population proportions is not equal to 0, we will calculate the p-value as follows. The p-value or probability value equals the probability of obtaining a z-test statistic greater than or equal to the one we obtained in absolute value multiplied by 2. Why is it multiplied by 2? Because we're agnostic. We're interested in considering very extremely positive z-test statistics or very extremely negative z-test statistics. The point is we will reject the null if that probability value is less than or equal to alpha, where alpha is typically 0.05. Right? And again, the p-value is simply the probability of obtaining a z-test statistic as a more extreme than the one we obtained under the assumption that the null is true. Then we can make a conclusion to reject or fail to reject the null. And in this case, it's important to subsequently interpret your conclusion. With this kind of approach, with a difference of proportions, the null hypothesis is saying that these two population proportions are equal to each other. There's no difference. The alternative is that they're not equal. Then we can also calculate a 95% confidence interval. We take the point estimate for that difference of proportions in the population, and we add and subtract the margin of error, where the standard error is calculated as before. We're going to reject the null if that difference, all right, for that difference in the population being 0 versus the alternative that the difference is not equal to 0, if that z-interval does not include 0. So if that difference of proportions, if that z-interval is centered away from 0, then that suggests we can reject that null hypothesis. So you can see that p-values, test statistics, compared to a critical value, and the confidence interval, they all can lead to a similar kind of conclusion. So we're going to go through a few examples of just going through the steps of hypothesis testing for a difference of proportions.